All right, so in this video, we are going to sketch a couple of piecewise functions. So in order to sketch a piecewise function, you need to know how to sketch each function individually. So let's start with the first function over here, which is absolute x plus 2. That's just an absolute function that's been shifted left by 2 units if you know your transformations. So our vertex is over here at -2, and then it's just an absolute function. Just looks V-shaped. Negative x squared plus 2 is just a quadratic function. It's been flipped upside down, reflected in the x-axis, and it's moved up by 2 units. So it just looks like that. And now we want to combine these two together. So when you're drawing a piecewise function, the most important thing is to mark the x value, which is basically the key point. So -1. Now if I sub in a -1 into this equation, -1 plus 2 is +1, and the absolute of +1 is also +1. So this function is going to be over here at +1. Since it's a less than equal sign, it's going to be a filled dot. Anytime you have an equal sign, it's a filled dot. And then we know that this point over here corresponds to this over here. And because it's less than, I just have to draw the left side of this function here. So it's just going to look like that. Now let's sub in a -1 into the right side of the function, which is the second equation here. -1, remember to do the square first. So -1 squared is +1. That's -1 because we have an extra negative sign here, and -1 plus 2 is also +1. So we would put an empty circle at +1, but there's already a filled dot over here. So it's the same point, basically +1. And then I just want to draw the right side of this function, which is just the remaining of this over here. It's just going to look like that. And that's how we draw a piecewise function. So since this function, these 2 points touch over here, this means that this function is continuous everywhere. Basically no discontinuities. Let's go to the second question over here. Our first function is a square root function. Square root of x, no transformations, just looks like that. Our second function is an exponential function. It's exponential growth. It's going to look like this. We have an asymptote at y equals 0. Now I want to combine these two functions over here. So again, I'll start with the most important thing, which is marking my key x value, which is +4 in this case. If I sub in +4 in the first equation, the square root of +4 is just 2. So I'm going to put an empty dot over here because it's less than 4. And there's no equal sign. And then I'm going to draw the left side of this because the first function is the left side if it's a less than sign. So it's just this little bit over here. It just looks like that. Now I'm going to sub in 4 into the second function. 2 to the power of 4 is 16. Oh, by the way, I can label this as 2. 2 to the power of 4 is 16. 16 would be very, very high. It would not fit in this graph, but since it's a sketch, I'm just going to label 16 over here. It's going to be a filled dot because there's an equal sign over here. And then I just want to draw the right side of this, which is basically going up at a very steep rate. So it's going to look something like that, kind of overlapping with my equation. But like I said, not enough space in this sketch. Technically, this value of 16 would be much higher, but I think you get the idea. And then since these two graphs do not touch, we can tell that it's discontinuous at x equals 4. Let's go to our third and final question. 1 over x is just a reciprocal function. Just looks like this. Has a asymptote at x equals 0 and an asymptote at y equals to 0. Negative x is just a linear function with a negative slope of 1. So it just looks like that. Let's combine these two functions over here. You know that our key point is positive 1. So positive 1, if I sub in 1 into this equation over here, 1 divided by 1 is just 1. And it's going to be an empty dot because there's no equal sign there. And now I have to draw the left side of this function. So basically, I got to draw the left side of this point. So you start going up like this. And then on this side, it's going to be the whole thing over here. And label your asymptotes as well. So this is x equals 0. And we'll label the other asymptote on this side because it only applies to this side over here. Let's do negative x next. So if I sub in 1 into this, I'll get negative 1 with an equal sign. So I'm going to put it as a fill dot. I'm actually going to cover this. I'll relabel the point 1 over here. This is negative 1. And then we're just continuing the right side of this function, which is a linear function with a slope of negative 1. And again, these two functions don't touch. We can tell that this function is discontinuous at x equals 1.